Hello, in this video we're going to continue with the last topic in chapter 6, okay, which is the method of sections. So just to recap, you have learned about the basics about simple truss, and then we have used the method of joints to solve problems related to simple trusses, more specifically to solve for the force developed in the members. Okay, and in part 3 we have learned about zero force members, so it is possible to have members that do not support any load. Okay, and in this video in topic 4 we're going to learn a new method, but we want to solve for the same things, which is the forces developed in the members. Okay, so this is using the method of sections. Okay, so this method is used to determine the loadings within a body, just like method of joints. And if a body is in equilibrium, any part of it is in equilibrium. So in a way, you can cut any part of the body and it will be experiencing the same force. So to find forces within members, what we do is we cut. Okay, an imaginary section is used to cut each member into two and expose the internal force as an external force. Because as you know, let's say you have this structure. Okay, you have three members, A, B, C, and you have a force acting on it. This is an external force, and the internal forces are not seen. Okay, the internal forces are not seen, but using this method you can cut. Okay, you can cut here, for example. So if you take this portion, then you will see that it will have force F, this is B, and then you can treat this as an external force because you have already cut the members. Okay, so when you cut a member in tension, you'll have these two portions. Okay, this is this part, this is this part, and in the middle we have the reactive forces. Okay, it will be the same thing for compression. This is the original compressive force outside, and then you cut in the center, then you get these two. Okay, that is the basics. So consider the truss shown here and the section AA. So this AA is a section used to cut this truss. Okay, member forces are equal and opposite to those acting on the other part. What that means is you have the left side here, ABG is the left side. So we have A, this is B, this is G. And then you see that it's halfway cut, so we don't have the full members BC, GC, and GF. Okay, and on the other side, take this right side, we have C, D, E, F. So we have C, this is D, E, and F. And similarly, CB, CG, and FG are not in full. So what you get if you join these two, you get the full truss. Okay, and what it's saying here, member forces are equal and opposite, means that if FBC is going from B to C, then FBC here will be going from C to B, because they have to be equal and opposite. They have to be in equilibrium. Okay, so that's it basically. So from this diagram, as an example, we can solve because we are treating these forces as external forces. Okay, so the procedure is, first we decide the section of the truss. Where do you want to cut the truss? This will be depending on what you have to solve for. Okay, so it depends on the question. Next, we determine the truss's external reactions. So this is the support reaction. Okay, after you cut, what are all the external reactions? And then we use equilibrium equations to solve sum of F in X direction equals 0, sum of force in Y direction equals 0. And then we draw the FBD of the sectioned truss. Which one do we choose? Because as you cut, you know you have two parts. Okay, so we choose the one that has the least number of forces acting on it, just to simplify things. And then we find the sense of the unknown member force. Okay, so we need to find the magnitude and direction of the forces developed in the members. Okay, then how we apply the equation of equilibrium. How to do this? Because all the forces are now external forces, so we can calculate the moment about some point, and then we can find a third unknown force from moment equation. So moment equations are used more here, okay, because it simplifies things. Moment, as you know, if you calculate the moment about a specific point, the forces acting on that point will not be considered. Okay, so we'll go through an example. Okay, so determine the force in members GE, GC and BC of the truss. Indicate whether they are in tension or compression. So we identify the truss GE, GC and BC, and we find that they can be cut using a single cutting plane. So the cutting plane is this, AA. So you're cutting through. So what we have here are external forces, 400 and 1200 newtons, and this is a pin support, so you know that it will develop forces in two directions. This looks like a roller. It's not very clear. It looks like a roller, so only one force. I'm not going to write the direction yet. Okay, so we choose section AA since it cuts through the three members. Of course, this is already done. We draw the FBD of the entire truss because first we want to determine support reaction, AX, AY and DY. Now, this could be assumed. Okay, the direction could be assumed, or you could do the analysis. For example, 400 newtons is in the X direction. The only other force in the X direction is AY. So of course it has to balance this direction. So this is to the right, this is to the left. But for AY and DY, it's not that simple. So you can just assume first. Okay, and then when we do the balance equation, we will know whether the assumption is correct or not. So first, AX equals to 400. That is straightforward. And then for AY and DY, of course, you can't use sum of force in Y direction because there are two unknowns. So we use moment. So here, choose to do moment about point A. So you have to deal with these three forces. Okay, 1200 rotating about point A will be clockwise, so negative. The distance is 8. 400 will also rotate clockwise, so minus. The distance is 3. And dy, assuming this direction, it will rotate counterclockwise, so positive. The distance is 8 plus 4, and then you'll get dy as 900. So because this answer is positive, that means your assumed direction is correct. Okay, now we have dy. You can solve. I guess you can do sum of force in Y direction. Should be quite easy. So AY we assume is positive, minus this. What else? Plus 900. Okay, and you get positive answer. That means this is the correct sense, correct direction. Okay, so once we have solved the external forces, okay, this is the original diagram. This is with the external forces. Remember, we are cutting through here. So do you take the left side or the right side? Okay, so the one that has less forces will be on the left side. Okay, because it only has AX and AY. On the right side, there's 400, 1200 and dy. So we take the left side because you can solve the force in these members GE, GC and BC using either side. So we take the left side. So draw FBD for the section portion. Okay, only the left part. And this direction needs to be assumed as well. So let's just do a quick analysis. We have only AX and AY, right? Originally, only these two. So what will be the direction to balance? Let's see, let's do this first. 300 newtons is going up, so this 2 doesn't count, so we need FGC to go down. Okay, so this will be the correct direction. And 400 newtons is going to the left. Do we balance both going to the right? Okay, so that's quite subjective. You can typically, however, we can assume the direction is going in 10. So the easiest thing to do is to solve for one of the member forces. So I choose to solve it as moment about point G because these two forces are going into or out of point G. So if you solve the moment here, then you can ignore these two forces. Just take FBC. Alright, so you can pause to analyze the equation. As you know, the negative and positive depends on clockwise or counterclockwise. And just check if you have the right final answer, as in positive, that means you have assumed the correct direction. Okay, so this is done. We have two more. You can actually, there's not one way to solve this, so you can analyze and choose whether you want to solve for moment about another point or what. Okay, so moment about point C will surely give you FGE. Okay, and summation of force in the y direction will give you FGC. So again, you can pause to analyze. So that's it for this topic, and we will continue with practice questions in class.